mutability. So what is mutability? It's the quality of being changeable. And because we're starting to work with data is something that can be changed easily. And the easiest way to demonstrate this is by looking at an example. So let's say I'm working with a list. Okay? So 1, 2, 3. Simple list. So my list is 1, 2, 3, right? Now, let's say I want to change the last element to 10. Well, I can actually do this pretty easily. I don't need to define another list being 1, 2, 10. That would be very, very, very tedious, right? Because then every time I want to change an element, I need to define a new list. There's got to be a better way, and there is. So my original list is this, and I want to make it into this list right here. Well, so what I can do is I can access the third element in the list, which is the second index, right? And I can change it to 10. So this doesn't do anything because it's assignment, but internally the list has changed. So now my list that was originally 1, 2, 3 has turned into 1, 2, 10. So this is mutation, basically. This is a mutation operation. And let's say for some reason I want to decrease the first element by 1. One way I can do that is I can just do minus equal 1, and I get my list to be 0 to 10. So these are two examples of mutation operations. We'll see some more mutations operations as we go on, but I just want to introduce the concept right now. And to introduce the concept, I will also give you a challenging problem to think about. So this is fairly challenging. Oops, let me not include this because this gives you a hint. But yeah, we'll go through this. Okay? Alright, so what we want to do is we want to reverse a list without a return statement and without using list of this special syntax that reverses the list. Okay, because that's a cheap way to go out. So how can we do that? So what this is basically asking is we want to reverse a list without creating a new list. So now the best way to go through this is to just go through some examples. So if I have a 1 element list, I know that's just going to return itself. Okay, I don't have to worry about that case. But let's say I have a 3 element list. That ends up being 3, 2, 1. How do I get this? Well, if I have only this list, one way I can do that is I can switch the first and third elements, the first and last elements basically, and I get this, and I don't need to do anything with 2. Okay, this is interesting. Let's say I have a 4 element list. So this turns into 4, 3, 2, 1. So what am I doing here? I'm switching the first and fourth element and the second and third element. So in terms of indices, that's the 0th and 3rd index and the first and second index. So this is going to be important when we actually write code, because when we access these elements, we're doing it based on indices, not necessarily what order they're in the list. So that's important. And let's just look at one more example. So if I have a 6 element list, that's going to change into 6, 5, 4, 3, 2, 1. Okay, awesome. So now I'm going to deconstruct this one because I think this is the most demonstrative. So what I'm going to do is I want to switch 1 with 6, right? So this is going to be my switching operation. Okay, so 1 has to swap with 6, 2 has to swap with 5. And the reason I'm doing this in terms of swaps is because I can't define a new list, I can't return a list, and so I basically need to do this in place. I need to change the original list. So this list that we put in here is going to change when it comes out. That's the key idea here. And this is mutation at its core, it's mutation. So then the 3rd and 4th elements are going to switch. Okay, so this is my switching operations. So this is in terms of the elements. I want to do this in terms of indices. Okay, so I know this is going to be the 0th index and the 5th index. Okay, and I know this is going to be the 1st index and the 4th index. And I know this is going to be the 2nd and the 3rd index. So notice that you see a pattern immediately, that these indices always add up to the length of the list minus 1. So in this case, because it's a 6 element list, the length of it minus 1 is 5. So we can use this in our code. So now to generalize this, let's say I have some 8th A element, then I know that this is going to switch. So if I want to switch the A element with some other element, I know in terms of indices, this is going to be the, let's see. So it's going to be, if it's the 8th index, actually this is a little confusing. So there's an element A, okay? And I'm going to say it's at the 8th index, okay? Since indices are always i's usually. Okay? Actually, I changed my mind. I want to do kth index, okay? I want to now switch this with what? Something that ends up adding to the length minus 1. So I take the length minus 1, okay? And what do I add to k and length minus 1 to get, so if I add it right now, I get k plus length minus 1. How do I add something else and get length minus 1? So that's a little confusing, but the answer is you just subtract k from this. So you subtract whatever the kth index is. So this is a general idea here. Okay, so we want to always swap the kth index with the length minus 1 minus kth index. So, and we can confirm this because we can see that the 0th index is flipped with the 5th index. So if it's a 0th index, then it's just flipped with the length minus 1th index. If it's the first index, then we switch it with the length minus 1, which is 4. So there we go. So this is a little hard intuitive leap to make, but if you just go through the examples, it's not too hard to see. Alright, so now let's write code. So, I just need to basically go through and swap the elements of this list. How should I do that? So I know I need to iterate through the list. Okay, I'm actually going to define the length. So I don't want to keep on writing the length of the list because I know that's going to be pretty important. I'm just going to define that as n. Now, I'm going to say for I, or for k in list, since the k is going to be our, I actually need to do this in terms of the length of the list. And so a good way to do this is to use the range function. So the range, and do I even need to go through the entire list? I really only need to go through half of the list, because then I just need to switch this half with this half. And in a case where it's odd, I just need to switch the first one with I can just switch everything up to the middle element with everything after the middle element. So basically, what I can do is, if you can confirm this on your own, but it's just n4 divided 2. Okay, so I just need to go up to that, and I need to swap it. So how do I swap? Well, we just defined the idea here. So I take my list, take the kth element, I also take the n minus 1 minus kth element, and now I swap them with each other. So list of n minus 1 minus k, and if you remember from earlier in the course, this is a very easy way to swap elements in a list. Swap values basically. Okay, so, and then that's all we need to do because we don't need to return anything. This mutates the list. So now we're reassigning the indices of the list to different values. So this is how mutation works. So this is a pretty tricky example, but let's just make sure it works. Okay, and it works. So this is how we reverse a list without, oh wait, JK. We actually don't know if it doesn't work because I didn't write any tests. For some reason I thought these were like voodoo tests, my bad. So what we can make a list, so let's just make a list. So if I have, so I'll just call this test make list. So remember we wrote that make list method. It's going to come in handy now. Make list is not defined. What? Really? Why is make list not defined? Oh, awkward. I need to call it interactively. Man, I'm making a lot of mistakes today. I'm sorry. So here we go. So if I define it interactively, it then loads the file. So now I can do that. So test is going to be make list, and now I'm going to call test on. So test is this basically, the 1 through 10. And so now if I reverse it, this is what's going to happen. So I'm going to reverse test. Nothing's going to happen initially because this doesn't return anything. But now if I look at my test list, it's changed. So this is the key to mutation. So if I define another list, 1, like, let's see, 2, 4, 6, if I reverse that list, nothing's going to happen, but it's internally going to change the list. So this is the idea of mutation. Previously, what we've seen is we call a function and return something, and we're done. But now, the function doesn't return anything, but it changes the list internally. So this is the usefulness of mutation.